you, Joe. So, hi everybody. My name is Nicole Wyche. I'm the Industry Decarbonisation Manager for WWF, and I started working on steel at the beginning of the year, so it's still sort of relatively new for me. And Kathy asked if I would give a little presentation to just update what's happening in steel decarbonisation in Australia. I was kind of a bit concerned that you guys already know this because I know how awesome everybody is in this group. So it's a fairly basic summary, but nonetheless, let's go and have a look. So I always start with my lovely picture of a Carnaby cockatoo here to just remind me to say that I'm coming to you from the beautiful Wadjuk Noongar Nation, and so I'm just outside of Perth in Western Australia. So because we're WWF after all, it's always good to remind people why we're here. It's about the emissions reduction. And I also wanted to just let people know that we have actually updated our corporate statements about when we wish emissions reductions to happen. So, and now our statement is that we are wanting to have net zero by 2038, which is a lot earlier than the NDC's targets at the moment. So to do that, that would require 67% reduction in 2005 levels by 2030 and 90% below 2005 by 2035, and then net zero by 2038. So for the steel industry itself, if you have an average across all production techniques of currently emitting about 1.85 tonnes per tonne of crude, 1.85 tonnes per tonne of crude steel, then that has to go down to less than 0.1. So it's quite a challenge. So for our 2038 target, that gives us 15 years to resolve most of the emissions of the steel industry. You can't ever get to real zero, but you can reduce it quite a lot. And I put this here just to mention, last week I was at the iron ore conference in Perth, which is a fairly substantial conference of iron ore producers, but also metallurgists and anything to do with steel manufacturing. And I was kind of pleased to hear there that even though there are a lot of technical challenges for the industry, there wasn't anyone that didn't think that the technical solutions could not be up and implemented within the next 15 years. So that's still sort of a bit of a steep curve. But on the other hand, a lot of the presentations that were given at the time still refer to the period of 5 to 15 years as a short-term target. So, you know, for us at WWF, that is kind of the zero target period. So I guess in the course of my work so far, I've sort of changed how I look at the 2050 target, and I'm starting to really wonder if this is sort of a disincentive for people to take a bit more action. Anyway, so on the right-hand side, there is just a little emissions curve that shows the emissions increases of the steel industry. And the blue line is the, sort of later introduction of Chinese steel production and how quickly that occurred. But the green line on the right is actually the decarbonisation rate that we should actually be having at the moment. So that's just the background from the emissions point of view. This everybody should mostly know, but just in case there's someone here that isn't so sure about it, what the problem is with conventional steel making is that in a blast furnace-based steel making, so to make steel, as everybody knows, you put iron oxide or iron ore in the top, you strip off the oxygen using coal and limestone and other fluxes, and you get iron coming out. That's pig iron, crude iron, and then you convert that, usually using a basic oxygen furnace, into something that you can make into your iron steel products. So the emissions that come out of the blast furnace process is up to 2.3 tonnes of CO2 per tonnes of steel, and if you include methane from coal making, then you have from coal mining, then you have over 3 tonnes of CO2. And this blast furnace, the basic oxygen furnace production route, is over 86% of the entire sector emissions. So this really is the issue. What do we do? So the solutions are to replace that with something else, replace the power source with renewable energy, and replace your coal and gas with some other reductant that's used to strip off the oxygen from the iron. So, and at the moment, the favourable thing for that is hydrogen-based reduction. So over here, for this route, here are some options for what to replace it with. A lot of people are advocating for direct reduction, preferably using hydrogen, although probably initially gas as we change over. So that works by you just drop your iron ore in the top, and it has a gas reduction process, and your pig iron comes out the bottom. POSCO have gone from a slightly different technique, fluidized bed technique called Hydrec, and the other techniques that are available are your sort of hydrogen-based reduction banks that you see. Globally, people are taking this up quite well. People probably saw that H2 Green Steel in Sweden, they just did the biggest private capital raising in Europe for this year, where they raised $1.5 billion to build a green steel plant. In an ideal situation, and because I'm from WA and I'm obviously very interested in how iron ore fits into this, if you have nice high quality iron ores or you have scrap metal, you can just take those things and put them in an electric arc furnace and make it steel that way. But not everybody is quite in that position. So here's a little slide just summarising what Australian steel makers are doing at the moment. So for the blast furnace producers, we have GFG Alliance in South Australia. They are planning to replace their blast furnace with an electric arc furnace that they've already purchased, and they also have a longer term plan to build a 1.8 million tonnes direct reduction plant. Their aim is to have renewable energy for that hydrogen-based direct reduction by 2025. And they're in a very good position because they're going to have access to the South Australian government's hydrogen electrolyser, and they have their own solar and wind farms under construction. It's a very unique situation that they have there because they also own their own magnetite mine, and all of this is happening in like a 50-kilometre radius. So you have all the ingredients there to do a good thing. And they actually did some hydrogen-based direct reduction pellet production in 2022 as a test to see how their own ore deposits could be used to make hydrogen pellets for hydrogen reduction. And their emission reduction target is carbon neutral by 2030. So BlueScope in New South Wales, they have an emissions reduction target of 12% by 2030 and net zero by 2050. They've got a number of research projects relating to emission reductions. And people can correct me if I'm wrong, but they have pledged about 150 million initially. But they also have announced relining of their blast furnace to continue that, and that will cost them about $1 billion. So electric arc furnace producers, we have David here from InfraBuild. InfraBuild has also said that they would like to have an emissions reduction target of carbon neutral by 2030. Electric arc furnaces are in a good position overall because just by changing their energy to renewable energy, they can actually reduce their overall emissions by about 76%. Not that that's necessarily easy, but it's easier than for a blast furnace production. New technologies.
Sorry, just
Australia.
to jump in.
Yep.
Sorry to jump in at this point with David. How are you doing, David Bell?
Doing well, Ed. Thank you kindly.
Yeah, good, cool. Just regarding your hot rolled steel, universal beams, universal columns, that's still in a blast furnace, and there's talk of the electric arc furnace coming online 2025. Can you talk to that at all? It's just relative to what's being said here, you know, in terms of it's very relative to the steel industry in Australia. Absolutely. Really relative to what we're talking about here.
I can't talk with any authority for what the GFG Alliance plan is. That's not my patch. I can talk for the InfraBuild side, for our smaller hot rolls and our reinforcing steels and others that we make from an EAF point of view. But yeah, I have no more visibility than everyone else does from what you read in the papers from a GFG point of view, other than to probably build on what you've put there, Nicole, which is all, you know, as far as I can see, fantastic and spot on. Was an announcement yesterday, Monday, with Anthony Albanese and others around the hydrogen that will ultimately help feed the aspirations there, and the fact they've turned off the coke ovens as well. But sorry, Ed, I can't talk to the larger hot rolled and hot rolls and that come out of the Whyalla business.
No worries. Sorry to interrupt you, Nicole.
No worries. That's okay. We should have time for questions at the end. And you know, it's good to see GFG doing that. But you know, yes, they turned off their coke ovens, but they are still using coke, so they're importing coke until their electric arc furnace is up and running. But that's still a step in the right direction. As far as new technology goes, there is a company in Australia called Calix Limited, and they have, as well as taking the best acronym, got a technique called zero emission steel technology, which is basically a kiln-based reduction technique, a little bit like DRI, where you drop the ore on the top and it gets reduced, and at the bottom comes a direct reduced product. So they have a test plant in Bacchus Marsh in Victoria, but they're trying to get funding to upscale that plant somewhere, preferably in Australia, to do a bigger scale test plant. In Western Australia, we have a new company that sort of appeared out of nowhere called Green Steel of WA. They are now partnered with Danieli, who's the EAF provider, one of the major EAF providers. And they've actually got a $2.7 million grant from the WA government to build an electric arc furnace scrap recycling facility in a town called Collie. So Collie is an old coal town of Western Australia, and as part of the funding to revitalise that area, this particular potential steel recycling mill has been given that funding. They haven't made a bid yet, but it's pending. The same company's also got a plan for a direct reduction plant, albeit a gas-based one, for the Midwest. So an Oakajee port, which is sort of a major port facility about halfway between Perth and the Pilbara. So in the Midwest, there actually are some magnetite-based iron ore deposits. Foreign investment is a little bit harder to track until they make announcements, but a lot of companies are looking at Australia to see whether or not it's better to build their iron processing plants in Australia or put them somewhere else. So Nippon Steel is looking, as is Baowu. They have partnerships with other companies, but it's not just Australia they're looking at. They're also looking at other countries. The biggest investment so far comes from POSCO. So they've invested at the moment a total of $40 billion in Australia. So 28 million of that is for green hydrogen projects and about 12 billion for iron ore export related things. At the moment, they have a plan to build a direct reduction facility in one of the strategic industrial areas in the Pilbara. Back to South Australia, because it just came up. I have to say that having spoken to all of the governments related to the steel industry, South Australia definitely stands out as showing some leadership in that space. So we were quite impressed when we spoke to them about the sort of thing that was going on. It was very well coordinated, very proactive, and very well thought out. So they have a number of things that they've done this year. Some of them are listed here. So the one that's very popular is the Hydrogen and Renewable Energy Act. So what they basically did is they took all of their legislation to do with hydrogen and renewables and they put it in the one act. So people only had to deal with the one thing. And they also introduced a sort of permit that acts a bit like an exploration permit in the mining industry, whereby renewable energy people could go and do a little bit of testing to see if the project was feasible or not without having to make higher level commitments to it. So they could sort of acquire land to test out whether their model was feasible or not. They have a green paper on the green energy transition and a South Australian economic statement that specifically says we would like to be a big player in the green steel and renewable energy space, as they already are. Their industry capability network, a lot of states have these, but theirs is actually embedded in the government, which allows them to move it along a little bit faster. So that's for identifying what sort of skill gaps they have in those kind of industries, what they're going to need and what are the training requirements and how to deliver those. They have their hydrogen jobs plan, which is the main funding source for some of the things they're doing. So they're building a world-class hydrogen power station. Their electrolyser is the one that people hear most about. It's quite a big electrolyser. And also storage and export facilities. So they have a steel strategy coming this year. It should be finished by the end of this year. And a special steel task force that's looking at that whole range of opportunities that surround that area where GFG Alliance is operating. It's a port, mine and steel production plant in a very small space, which is quite good. A lot of environmental and social governance data has been compiled already in a database for their planning purposes about where you can have these types of developments, including renewables. They've so far spent themselves about $750 million. And as I think Joe said, Anthony Albanese was there this week. And part of that was to announce a $100 million state federal partnership. And that's for developing a hydrogen export facility. So that's Port Bonnefon. So they're doing lots and lots of stuff and it's all quite good. They also have lead agency status nationally for developing out these kind of policies. So it's quite, I suppose, pleasing in that what they're doing, which is largely quite good, is probably going to get rolled out to other states. Right, back to WA, and I just wanted to say a few things about part of the equation that doesn't always get discussed, although is getting a bit discussed a little bit more now, and that's the iron ore side of the equation. So 90% of deposits are in WA and 80% of those in the Pilbara, so that's up in the northwest of WA. At the moment, people would think, great, it's our number one, Australia is number one leader in iron ore exports. Is this going to be maintained or not, is the question when we go to a different type of steel production. So at the moment in Australia, there are two types of iron ore. There is what they call hematite goethite. Goethite's just a geology name for rust, and other types of oxidized iron ores. And these make up 98% of the iron ore that we export. So our lump and fine direct shipping ore market at the moment, 98% of this ore type. They're typically quite low grade. They're sort of less than 67% iron, and they have a lot of contaminants in them as well. The other deposit we have in far lesser amounts is magnetite deposits. South Australian deposits are magnetite. In Tasmania, you have Grange resources with a magnetite deposit. WA has a few, but not super many, because up until now, they were very unpopular because they're very, very low grade, less than 40% iron ore. But however, it's really easy to upgrade that iron content because they are magnetic. So you can use magnetic separation methods on that. So what that means is you can make a suitable product out of magnetite ores for an electric arc furnace processing methods, whereas you can't at the moment from the hematite ores. So this is one of the main technical problems. If you use hematite, it's far too rich in contaminants and it makes too much slag if you try to use it for DRI or for EAF. So the problem really is what to do about this. So how that works is still a little bit to be resolved, but the people believe it is possible to resolve it. So, there's a lot of things you need to make green steel happen. You need green electricity, you need green hydrogen, you need the process knowledge to do this kind of thing in the first place. You need sort of standardization across the globe of what does green steel mean? What's the definition of that for an export market? There has to be a, tons of carbon dioxide per tons of steel figure that we come up with. But you also need a solution for processing both of the ore types. So if we are going to replace a blast furnace, we still have a problem for these. If you have high quality ore, I mentioned that before, or scrap metal, that's fine because you can put them through processes that already exist, mature technologies, into an electric arc furnace. If you have hematite ores, you can't because they're too dirty. You can still put them through direct reduction plants or the other technologies that exist, but then you have to do something else with it to get rid of all the rubbish. So people at the moment are most commonly promoting some sort of smelting to happen after that before you can then put it into something else like a basic oxygen furnace or an EAF to make steel. There has to be another process to remove all the contaminants from it. And in terms of what choices that gives the industry, either you can start to make your sort of hot briquetted iron, which is what comes out of a direct reduction plant and can go into an EAF if it's clean enough, or you upgrade your ores some other way to make a higher grade product. So using magnetite, that's okay, got the technology for it. Other ore types, not quite yet, under research, under progress. But the significant thing for that spatially as to where this is going to happen in the future is it means you probably see a decoupling of iron making and steel making. They no longer have to necessarily happen in the same location. So at BlueScope, you have the whole process on one location, but it could be that perhaps in the Pilbara, we start making your crude iron there and this sort of product gets shipped to wherever you're making steel. That's the most likely scenario of how it goes. In WA, the government was very late to the uptake of starting to look at this. I think they're very satisfied with the current sort of dig and ship bulk exports that we have at the moment. But this year, they have actually released quite a good report. And the aim of that was to look at the question of, can the state competitively deliver across the various stages of the green steel value chain? And these were the scenarios that they looked at. They looked at just green iron ore mining, which is happening. Iron ore companies are trying to mine in a much greener way, electrification of their fleet and that sort of stuff. Perhaps we could just make green pellets, so pelletizing iron ore without doing anything else to it, but using renewable hydrogen perhaps. Maybe we could make hot briquetted iron through a direct reduction process using gas. That's the number 3. Number 4 was the same, but using renewable hydrogen. And number 5 was let's make steel in Western Australia. So of all of those, they did decide that 2 and 3 were the most likely economic ones, with the caveat providing a market emerges for that, which it absolutely will. Joe, did you want to ask a question now, or did you want to hold it?
I had 2 quick questions. One,
yep.
Fortescue Future Industries seem to be conspicuously missing from your roundup of the various players.
It's coming. Yeah,
Okay.
coming. Yeah,
And
okay.
and two was obviously cement is the other big building material emission problem. And
Yeah.
I heard you say, well, if we use the hematite, it produces too much slag. Well, for me, slag's a good thing in cement because it can replace cement. So I'm just
Yes,
wondering if there's
I can't talk to that. I don't know about the applicability of slag that comes off, but that was definitely discussed a lot at the iron ore conference by metallurgy nerds. But don't ask me that question. I'm not sure how suitable the slag product from each type of furnace is for cement
Okay.
making. Yeah, but that comes up, and everyone's aware that there's a market for that.
Yeah, cool. Okay,
Yeah.
thanks.
So that will disappear from when blast furnace. Well, not disappear, but needs to be filled with something else when blast furnace production isn't used.
Yeah, just to add as well, just
Yeah.
on that slag, it's being used just because it's a waste product, but the concrete industry is recognizing the shortages of blast furnace slag, and it needs to move away from that being a need for low carbon concrete. So it's not the future, of the concrete industry.
Yeah, but there'll definitely be a slag when you change to melters and things. I just don't know what sort of material that will be. So, yeah. All right. So here's iron ore. We get to the iron ore producers now. So Fortescue is going to get a mention in this list very shortly. So iron ore producers themselves are scrambling around to work out how they're going to fit in the new green steel environment. And there is quite a lot of financial reward to be the first person to link up all of your scope 1 to 3 emissions with your trading partners and make an overall green product. So there's no lack of trying. It's not very transparent what work is being done and a bit hard to find out about, but everybody is on it and trying to solve this problem. Fortescue definitely the most vocal about it. So they're all researching what to do with Pilbara ores, how to solve that problem, because otherwise people just go and buy magnetite ores from another country, and there are huge, enormous deposits in places like Guinea, which would replace a lot of this market if there's no other choice coming up. So Rio Tinto, they're looking at melters just like everybody else with BlueScope, and they have the agreement with Baowu from China to investigate looking at melting in China as well. They have another very interesting project called bio-iron, which is a different way to make a pig iron product other than DRI. So essentially, they're using things like wheat stubble and they're treating it with a microwave technique, and they're making a pig iron like a HBI product that way instead of using direct reduction. It's very, very interesting because it does have sustainability potential for that area. They're looking at hydrogen-based HBI production, just like everybody else, and have agreements with all of their trading customers to try and sort out the whole emission chain. And they've also joined Japan's Green Value Chain Network, which is another initiative that they have. So BHP, same sort of thing. They're looking at melters. They've also got partnerships with Barrow and POSCO and HBIS from China and Tata. GFE Steel in Japan, they're looking at pathways for Pilbara ores, and doing a lot of electrolysis research. I didn't mention electrolysis, but that's kind of like the holy grail of sorting out steel decarbonisation, if you can produce steel via electrolysis, but it's still pretty lab scale stuff at the moment. Fortescue, very, very loud about it, which is, I think, good overall, but Andrew Forrest is the loud person. Other people in the company, like Christian Henning, will be very honest and say, well, we're not doing this because we're greenies. We've got an $800 million diesel bill every year, and if we electrify our fleet, that's something we don't have to pay for if we're generating our own renewable energy. And they primarily see it as a business risk as well. If they don't change over, the nature of their deposits is that they will be the most affected if there's no solution to the Pilbara ore processing issue. But they have very aggressive emissions reduction target. They set a goal of real zero, so no offsets, by 2030, and net zero scope 3 by 2040. And pretty much, working with the same sort of things as everybody else, but they actually so far the only ones to have produced a green steel product, hydrogen-based. It was only 150 kilograms, but you have to start somewhere. So the other significant thing they did is they opened a very large magnetite mine in the Pilbara, which is one of the few magnetite mines up there at the moment, called Iron Bridge. So that's helping them out a lot. There is another company down the bottom here called API. It's a consortium, a joint venture consortium between Baosteel, Mineral Resources, POSCO, and Hancock Prospecting. So these are the ones that are going to build the HBI, the direct reduction plant in the Pilbara. Research across the country, just quickly, there is a lot going on. The main processing research comes from a thing called the HILT CRC, which is Heavy Industry Low Carbon Transition and Cooperative Research Centre. So they're the ones doing most of the research for this, but of course CSIRO and other traditional places. There's also a Future Fuels CRC, there's a Scaling Green Hydrogen CRC, and there's another one called CRC Time, which is pretty much looking at sustainability, but doing a few other things as well to do with, you know, land impacts and that kind of thing. So there's plenty of work going on there. I just wanted to give a bit of a mention to this particular one though as well. This is a tool called Economic Fairways, and it was developed in combination by Geoscience Australia and Monash University. So they actually won this year's Eureka Prize for Sustainable Development. They have a couple of tools. The first one was called Hydrogen Economic Fairways Tool, and the second one is called Green Steel Economic Fairways Tool. And what it is, it's a spatial database that lets you stick in a whole bunch of parameters, like if you use X amount of wind and X amount of solar, and these are all your costs, electricity costs, hydrogen costs, all of that sort of thing. It lets you actually model roughly how much it would cost you to make either hydrogen or green steel in various places based on what facilities currently exist there. So it's quite well done. I encourage people to go and have a look at that. It's a neat thing. Monash and ANU themselves are starting to do, you know, reasonable calculations on just how much this kind of deployment is actually going to cost. Part of the problem has been that there really hasn't been robust numbers about those things, but they're starting to look at that quite intensely. So just, you know, how does this go? What will be the sort of scenarios of how this unrolls in the future? We have a bunch of risks in terms of meeting emission reduction targets and climate-related goals. So, you know, we can have a slow pace of transition. The rollout's not fast enough. There isn't enough hydrogen. Or the lack of hydrogen in WA is already sort of having an effect because people are signing long-term gas contracts for their new DRI plants and things like that. You can have an overall lack of investment. For WA, we still need over here a little bit of a change in what's our trading identity going to be for the future. They're very committed to being a gas exporter, whereas if we're going to adopt this with more speed, they need to start saying, rather than dig and ship, we need to do more processed products, which they kind of slowly, the ship is slowly turning, but it's not really quite happening fast enough. We also get a lot of feedback from our colleagues in Japan and Korea that the message they're sending to trading partners is not really enough about how we can help you out with hydrogen and renewables and other types of things. It's still all about how much gas you want. So a little bit of a challenge there. The other thing is that our government, at least here, and probably some other state governments, they always like to say they don't want to pick winners amongst technology. But what that seems to be doing is it just means they don't invest enough in a variety of technologies, because we don't really know what's going to be the winning steel production technology for certain ore types yet. So that means you have to spread the investment quite a little bit around. The other thing is, you know, the ever-present demand to cut red tape, which often means you just drop the ESG requirements for things. Awareness of that we're not the only country with lots of good things to offer. Brazil and Africa and the Middle East also have good opportunities for renewable energy. They have good opportunities for hydrogen. They have good iron ore supplies. So it's not just Australia that can win this race, and perhaps we should be a little bit more aware of that. So investment in people is a big thing as well. A lot of these new processing methods, we just don't have the skill sets for in Australia at the moment, and not enough people with those skill sets. So the time to start planning that would really be now. In WA, we're really feeling that in the energy construction area because we just don't have enough people to do that sort of rollout. So this is like a little neat scenario model that actually University of Queensland had it. And I thought this sort of summarises what could happen over here. So the horizontal line is kind of increased demand for green steel products, and this vertical line is increased regulation. So I kind of think maybe this is WA over here. We're still a little bit stuck in survival mode. We need to like stop doing what we've been doing and start moving a bit more aggressively to investing in the new things. Whereas maybe South Australia has embraced the new economy a lot more for obvious reasons, in that they sort of feel that they have to be doing this. They're a small state, and haven't quite had the same level of resources income that WA has. So different motivator, but they've used that motivation quite well to date. If neither of these things happen, we don't have demand or we don't have regulation, then whatever's cheaper is going to happen. And on the other side, if there's just high demand and low regulation, you will see people just going offshore to other countries to source iron ore and probably make iron there. So that's theories. We could discuss that all day, but in theory, one of those four things could be happening. And that's it. I just wanted to mention, I did put a few other slides in this deck, which I'll send around to everybody, that just talks about what we at WWF are specifically doing with this whole steel decarbonisation work. But I just will mention one of them, and that's the Science-Based Target Initiative, because they have just released a new steel guidance. So I think members of this group are pretty much aware of SBTI and what it does, but the new steel guidance came out literally 2 weeks ago. So there are some free webinars and things around that you can take a look at that with. And that's all. I hope people learned something out of that. Ladin has a question.
Thank you, Nicole. Two areas I just would like to raise. First of all, do you have a definition for green steel? We as KS, we try to avoid using green steel. Instead, we are using net zero steel, low carbon or emission steel, and some of our colleagues, they use fossil-free steel. And as far as I know, MECLA use low embodied carbon steel. So that's first of the question. And the second thing is, have you assessed the further processes like rolling and finishing when we produce steel? Thank you.
Yeah, good questions. And the first one is really super important. So at WWF, we don't have a definition, but we would be on the fossil-free side for sure. But the problem with that is that there needs to be a globally accepted definition, which probably will come out of Europe in the near future. But you know, it's very nice for environmental organisations to say we want it to be fossil-free or low emission. But if there's going to be a trading market in these products, I think there needs to be an amount of embodied carbon specified beyond which it can't be called green steel. So in answer to your question, no, there isn't one that I know of that's really workable for everybody, but that's a really important need. It's, you know, in the top 5 things of what people want, is particularly mining companies want someone to say, what does it mean? Because we need to know that to move forward. Yeah. And in answer to your second question, no, because there's only one of me and I can't look at the whole process. So I pretty much stop after the sort of crude steel bit. Yeah.
The majority of the impacts are coming from the steel making, of course, but we are also consuming a significant amount of energy, especially when we are reheating our byproducts like billets, blooms, and similar byproducts. And the finishing also brings lots of further, let's say, impact. So I think, you know, on top of steel making, further processes should be considered when you are assessing the whole life cycle of that particular finished product.
Absolutely, I couldn't agree more. And that's one of the things it's not. I don't think globally that's covered quite enough at the moment in the request for decarbonisation. And the other thing is that sort of there is a fact that when you go to sort of increasing the amount of primary processing we do, that you will have an increase in emissions that are associated with that. If you're going to start making, for all mined commodities, as WA is talking about, they want to have onshore processing to a certain level. The emissions will actually go up. So what the other numbers we need is, well, considering how much emissions we're taking out of electricity generation overall in the state, what does that mean? Are we still going up or are we going down in emissions? It's something that organisations like us start to need to be able to have an answer to, because in particular, the WA government is starting to say to people, well, we're going to do this primary processing, onshore processing, but how do we deal with the fact that that actually involves an increase in emissions initially until you get the full changeover? So yeah, there's a lot of things to do.